Good afternoon. My name is Adam Gordy, and today I will be presenting on combustion properties in a Rijke tube. The primary instrument that this experiment focused on is how a Rijke tube is able to contain sound waves in the form of a standing wave when one end of the tube is exposed to heat. Invented by Dutch physicist Peter Rijke of Leiden University, the Rijke tube is open at both ends, with a heat source at the bottom. Now, the tube has a natural resonance frequency, which is discussed later, but if the tube is excited to this frequency, the tube will begin to create a noise similar to that of an organ pipe. Now, this Rijke tube will be placed above a pulsed combustor, which will enable a controlled amount of fuel and air to produce and maintain a flame. As the name insinuates, the pulsed combustor will release heat as a function of time as in a sinusoidal format, causing the intensity of the flame to fluctuate with time as well as the pressure and velocity. During this experiment, qualitative and quantitative data were recorded as to how the system reacted during different heights of the burner. As the burner burned through the propane and presence of oxygen, carbon dioxide, water, vapor, heat, and light are all produced. However, this is not the whole story. Intermediate steps occur during this process, creating molecules if only for fractions of a second, but they do exist for a measurable amount of time, which is critical for the operation of the volt multiplier, due to the fact that these radicals, which is what they're called, will detach unpaired electrons which release photons. This is extremely relevant in rocketry, as the existence of these radicals will reveal if a steady or unsteady flow is being produced. We will also look for the amplitude and frequency of the pressure waves created by the combustion of the fuel through the tube. This frequency needs to be kept in check, for with the rockets, a combustion frequency lining up with the natural frequency of one of the engine components could lead to a disaster or a greater engine efficiency, depending on how the tube is designed, how the engine is designed. Along with the Rijke tube and combustion apparatus, several devices were implemented in order to take precise measurements of the amplitude and frequencies of the pressure waves. The primary device used to measure this pressure waves were the three piezoelectric pressure transducers. The piezoelectric effect is based on how crystals are able to generate electrical charge from an applied mechanical force, which in this case is the pressure wave. Now, when the combustion process takes place, the radicals will be formed through the process, which creates photons due to the excited unpaired electrons, in a process called chemiluminescence. The rate at which these photons are released can be measured by a photomultiplier tube, and by the forcing the photons to interact with a photocathode, as seen below, electrons are created and multiply through the tube, creating a current, which is measured and stored to see how the radicals are being created in time. The method of this experiment involved moving the burner up the Rijke tube to see how the pressure, amplitude, and frequency changed. The Rijke tube was measured to be about 70.5 inches tall, or about 5.8 feet. Each pressure transducer was placed in such a way that they were evenly distributed through the length of the pipe, at a quarter, half, and three-quarters of the pipe. In addition to this, a rotameter was used in order to measure the flow of gases through the tube during the experiment, although this was constant as to prevent undesired inconsistencies in the waveform. Now, the piezoelectric transducer was able to measure all the wavelengths that passed through the tube, which resulted in the measurement and voltages of every quantized frequency from 1 to 5,000 as an amplitude. To convert this, I used equation 1, which states that the decibel value of the amplitude, the sound pressure level, is given by knowing the fact that the pressure waves and the threshold for human hearing, which is 2.9 times 10 to the negative 9 psi. Using the table in the back of the report, I was able to find that the relationship for the piezoelectric transducer was to convert the voltage to pressure, and then to the decibel value of the amplitude, which is shown by the heights of 0 inches, both open and closed, 2 inches, and 7.5 inches. These values were chosen in order to be able to analyze how the amplitude and frequency will change when the burner is moved up and down the pipe. The significant value of 7.5 inches is the value at which the amplitude of any oscillations dies down to near zero, which results in a steady flame. It should be noted that by exposing the inside of the pipe to atmospheric pressure, the amplitude of the pressure wave also dies out, producing a constant flame. The relative phase angles were also measured, and they revealed how the phases of the waves measured at each tube were slightly different from one another, with the largest distinctions occurring at zero at the opening. This is important to note that these are measured in degrees, not radians, and are relative to the phase angle for the middle of the tube. Also, the estimated resonance frequency in the tube was measured to approximate at what frequency the tube would begin to create the pipe organ sound, which is noted by noting that the frequency is related to the speed of sound divided by the wavelength, which was 2 times the length of the tube. A resonance frequency of 9 95.8 was found, which makes sense because we hear the sound of the burner at about the resonance frequency at about 100 hertz. Another thing to notice was that the frequencies possessed a much larger amplitude when below 100 Hz due to the fact that the combustion of propane happens at relatively low frequencies due to the fact that it's a fuel burn. For something like an uncontrolled explosion, much higher frequencies would be recorded, which is why the pressure signal changes from the beginning to the end of the data recording. So what we have found from this experiment is that the propulsion technologies are not merely lighting fuel and hoping that an explosion does not occur. It's an intricate process that takes a great deal of research in order to understand and properly analyze. Great safety was used during this process, and we take care to make sure that no one was injured. We have seen that when the Rijke tube is closed off from atmospheric pressure and heat is added to the experiment in phase with oscillations, that the Rijke tube will indeed resonate. A further consideration would be to see how the change in mass flow rate would alter the frequencies of the pressure waves. Thank you greatly for your time. Any questions?